Hello. Thank you all those who watched my previous video the day before yesterday about the parallel structure of computation and physics that makes possible the implementation of a computation on physical hardware. I am Eric Lindell, and I would like to continue speaking about that topic by emphasizing the passive-active structure that is common to computation and physics. Passive and active are renownedly applied to consciousness. Passive mind, active mind. Passive is experiential, active is volitional, or doing. And passive and active in the case of computation would be respectively data and algorithm. What is the relationship between data and algorithm? Well, algorithm is active as the agent of change of data. That's what algorithms do, is they change data, and more to the point, that's all they do. They don't do anything else. Now, in the case of physics, passive and active are matter and energy. What is the agent of change of matter? Well, anytime you want to change matter's temperature, shape, velocity, or something else I can't think of at the moment. But bottom line, if you want to change matter, you got to expend energy to do that. And I think if you want to change matter's temperature also. Okay, so we have in this passive-active duality, we have the notion of the active as the agent of change of the passive, and that relationship holds for both the physical world and the computational domain. So that's one way we're going to argue that this passive-active dichotomy, common to both physics and computation, is not merely coincidence. I emphasize this because whenever I argue this point, I always get the same thing. It's just semantic coincidence. This passive-active duality has no significance beyond mere semantic coincidence, and I have to emphasize that that's not the case. There are arguments underscoring the significance of this parallel in the structure of both physics and computation. So that's one argument. The next argument, I think, is even going to be probably stronger. It is that the passive is always spatial and the active is always temporal. Okay, we have the temporality of algorithm, as I think we discussed in our last video. All algorithms are classifiable according to their asymptotic temporal behavior, with the main dichotomy being between polynomial and exponential time. Data is spatial. Now that's true when discussing abstract algorithms being carried out on a Turing machine. The Turing machine's tape, where the zeros and ones or whatever symbols you happen to be using are stored, are separated from one another by their spatial location. Now, this is not physical space. This is a kind of more abstract computational space. But bottom line is that in an official Turing machine computation, after every state change and output to the tape, the tape must either shift left or shift right. Okay, the key distinction here is between left and right, which are differentiated spatially. Okay, just like before and after are differentiated temporally. Okay, so there you have it. In the case of computation, passive computation, data is spatial. Active computation, algorithm, is temporal. Now, when we look at physics, are we going to find that passive physics is spatial and active is temporal? Well, let's have a look. Passive physics is matter. Is matter always located in space? You're darn right it's always located in space. Tell me one other place it can be besides space. Matter is always in space, nor does space have any meaning but for the matter that it contains. That's like probably a philosophy of physics or philosophy of science question to be elaborated in a different context. But yes, matter is spatial. Is energy temporal? Well, you're darn right it's temporal. That's why you have the idea of a kilowatt hour of energy. When energy is being output at the rate of 1 kilowatt, and it does so for 1 hour, the total amount of energy is a kilowatt hour. Okay, that power is defined as the temporal rate at which energy is expended. So energy is inherently temporal. That is to say, energy expenditures are inherently temporal. Energy potentials, different story. But matter or mass is a kind of energy potential. All right, so we now have our second argument that the passive-active dichotomy that is common to the structure of both computation and physics is not mere coincidence. And our two arguments are that the relationship of passive to active is the same in both cases. In both cases, the active is the agent of change of the passive. And our second argument is that in both cases, the passive is always spatial and the active is always temporal. This is huge in advancing our progress towards a unifying theory. We looked in our previous video at the common underlying structure of computation and physics. This time we have elaborated it to include this passive-active dichotomy. And that's going to prove very useful when we try to include consciousness in a kind of threefold unification of mind, physics, and computation, because the mind renownedly is dichotomized as passive and active, as is well known. But it's not well known that physics and computation are so dichotomized. So that's another step toward our unifying theory. Thank you all for your interest. Please stick around because it's going to get even more exciting. I'm Eric Lindell. Have a pleasant day.